Hello. So as we start into chapter 8, the second section, we have wrapped up looking at quadratics and how we can write them in both product form and sum form, factored and expanded. And now we're going to take a look at that connection in the quadratic web between equation and graph. If you remember way back at the beginning of the school year, we spent some time investigating parabolas and looking at some special qualities about them, and they were different. The qualities about a parabola are different than a line or an exponential curve in that with a line, you could look at a linear equation, and if we had a linear equation, you could see that a line would be increasing or a line would be decreasing. It would be simple to look at a graph and see the y-intercept, or look at the equation and see the y-intercept. Same thing with exponentials, in that you could see when it's increasing, you could see when it's decreasing. But with a parabola, it both increases and decreases. Or vice versa, it might decrease first and then increase. But we did note at that time that there were some very special qualities to a parabola. We looked at, before I go there, let's go look at the equation for this one in particular. So I've graphed this equation over here, the negative x squared plus 17x minus 42. When I graphed it, it looks like this. And if you were to graph this by hand, you would probably start a table, and we would maybe start our table at -3 and go to 3. That's typical. Or even to start at 0 and maybe go up to like 5 or 6. But if we did that, you wouldn't see some of the special properties about this parabola. You wouldn't necessarily see that idea of having that maximum point. You wouldn't see that idea of the symmetry that exists. You wouldn't be able to see that in the table. If you look over here, the symmetry in the table doesn't even begin until you get up to where x is 8 or 9. And that's not typical. Like, we would have no way of knowing that. If we were to just generate the table for this, like I said, most people would start here. And that means we would only see a portion of this graph. We would see a portion where, it was really low over here. We would see it start to increase. Maybe we wouldn't notice that it was quadratic in nature. But we want to be able to see those very special qualities about a parabola. We want to be able to, when we look at a parabola, we want to be able to see the vertex, where it falls. We want to be able to see those points that are important, like the x-intercepts. Those were some important points that we noted. I'll put those on there again, the x-intercepts, the vertex, and the y-intercept. All of those points are important. And of course, we could also find the mirror image of the y-intercept over here based on where that line of symmetry is. So those are all things that we want to be able to locate. Given a quadratic equation, we want to be able to locate those different things. So that's what we're going to focus on today. We're going to focus on ways that we can manipulate the equation without having to just guess at where the symmetry may fall. So I'm going to switch over here to a practice worksheet, and we're going to go through just several examples of being able to go through and find, as you can see what I have written here, we're going to try and find the x-intercepts, the x-intercepts, the vertex, the y-intercept, and then we're going to go through and we're going to graph the parabola. So we're going to start with this equation, y equals x squared minus 2x minus 15. And what I would like to be able to find is I'd like to be able to find the x and y-intercepts. So we can find them just like we find x and y-intercepts, whether it's a linear equation or whether it's an exponential equation. An x and y-intercept has to be where the graph crosses the x-axis and the y-axis. So let's start first with the y-intercept. I know it's down here as part C, but I want to start here. We know that with a y-intercept, this is where x equals 0. It's that point where x equals 0. So in the given equation, y equals x squared minus 2x minus 15, sorry about that, minus 2x minus 15, we can simply put 0 in for x and calculate the y-intercept. So I'm going to do that. I'm going to put 0 in place of x. And I'm going to get 0 minus 15. And I'm going to note that my y-intercept is at 0, negative 15. At 0, negative 15. That's one of those key points. All right, so the next thing I need to find my x-intercepts. And x-intercepts would be where the y value equals 0. So in this situation, that would mean I would be putting 0 in for y. And the problem I'm faced with now is that if I go and try and solve this, I'm going to add 15 to both sides. Let's just try that. I'm going to add 15 to both sides. And I get 15 equals x squared minus 2x, and now I'm stuck because there is no way to just get x by itself. So this isn't going to work. I'm going to erase that and back up. So I'm looking at this and I'm wondering, well, how else could I try and find this? And here's the thing. We spent all this time in the last 2 weeks before spring break. We spent all this time learning how to rewrite a quadratic expression in factored form. So I want to just take a look at this for a minute. I want to take a look at how would it look different if I went through and I factored x squared minus 2x minus 15 into factored form. If I made it, let's see, it would be x and x. It would be minus 5 and plus 3. If I rewrote it as a product, set equal to 0. So essentially, that's like saying, well, 0, this is a little side note over here, side note. 0 equals some factor A times some factor B. And if I do that, then doesn't it make sense? Then either A has to equal 0 or B has to equal 0. That must be the case here. So if it is the case that 0 equals x minus 5 times x plus 3, the only way that I can have this product equal 0 is that either x minus 5 equals 0 or x plus 3 equals 0. This is what we call the zero product property. The zero product property. And that says that if A times B, if the product of two numbers, two or more numbers, equals 0, that one of those factors has to equal 0. If this is the case, then I can now solve this. So I get x equals 5 or x equals negative 3. So it means I have two x-intercepts, which totally makes sense. We've seen that many times when we look at the graph of a parabola, is that we have two x-intercepts. So we're looking at the x-intercept of 5, 0, and the x-intercept of negative 3, 0. So right now, I'm going to go ahead and put those values onto my graph. So if I look at my graph here, I'm going to set up my quadrant. Now I need it to go down to negative 15. So I'm going to go ahead and draw in my X.
Miley.
That's my dog Miley and my daughter. I'm going to go ahead and put in, I'm going to count by twos, I think. I'm going to scale by twos. So that would make this negative 10. This would be 10. This would be 10. And this would be negative 10. So when I go ahead and draw this in, I have my x-intercept at 0. At 0, negative 15 would be right here. I'm sorry, that's the y-intercept at 0, negative 15. My x-intercepts were at 5, 0. And then again at negative 3, 0. Now here's the thing, it looks like this parabola will take this shape, but what I really need to know is I really need to understand and know where that vertex falls. What we need to remember is that when we are when we're looking at the parabola, the vertex is going to fall right in the middle of those two x-intercepts, and right in the middle. It is going to split them down the center. If we go back to the other graph that we were looking at, we can see that the center, the vertex, I'm going to take a look here at these points. If you look at the x-intercepts of 3 and 14, the very center of 3 and 14 is 8.5. So the line of symmetry in the vertex is going to go right through that point. If we come back to the points we're looking at, that means our vertex, to find the vertex, the x-coordinate, is in the middle of the two x-intercepts. So if my two x-intercepts are 5 and negative 3, I can simply take negative 3 plus 5 and divide it by 2. I can average these 2 points. So I get 2 divided by 2, that's 1. My vertex has an x-coordinate of 1, and now I just need to figure out what this y-coordinate is right here, what my y-coordinate is. But if I know what x is, and I know my equation, y equals x squared minus 2x minus 15, then I can simply say that x is 1, so I'm going to do 1 squared minus 2 times 1 minus 15, so I get 1 minus 2 minus 15, which equals negative 16. And I now know my vertex is at 1, negative 16. So I'm going to come back to my graph, and I'm going to put my vertex at 1, negative 16, which is right here. And then remember we talked about that symmetry point. This y-intercept is going to have a symmetry point right across here. Oops, right there. And now I've created 5 points that I can take my time, and I'm going to draw in a smooth curve so that I've got all 5 points on there. And I have a pretty decent picture of my parabola. And if we want to make absolutely sure, then we can go back. We're going to go back to Desmos, and I'm going to create a new graph, a new expression. Let's clean this out. And we're going to put that equation in just to make sure that we have things right. Y equals x squared minus 2x plus, nope, minus 15. And if we look at that and we look at our 5 points, we can see that our x-intercepts are at 5 and -3. We've got a vertex at 1, -16, and we've got a y-intercept at 0, -15, and then its partner would be over here at 2, if I can find it, 2, -15. All right, so we're going to go through this process again. So this is a process of trying to do this without a graphing tool, without turning to Desmos. We use that as a check, but these are all things we should be able to do quickly and without having to use any kind of graphing tool. So let's try it again. I've got another example here. This is my next example, example 2. This is a little bit different. This one, if you notice, it only has 2 terms. We've got y equals 4x squared minus 1. This time I'm going to start with the x-intercepts. We're going to find the x-intercepts and the vertex. So for the x-intercepts, we are going to solve the equation 0 equals 4x squared minus 1. We want to put our equation in factored form. So we're going to rewrite this as 0 equals, this is the difference of 2 squares. And of course, you guys can go through the generic rectangles and get that set up. But I'm going to go ahead and do this just using the pattern that we looked at last week before last. I've now got it in to factored form, and I know now that either 2x minus 1 equals 0 or 2x plus 1 equals 0. And then I'm going to go through and I'm going to solve each of these for x. So I've got x equals 1/2, or if I do the same solving over here, I get x equals -1/2. So my 2x intercepts are at 1/2, 0, and -1/2. Let's clean that up a bit. -1/2, 0. Those are my 2x intercepts. I know my vertex. To find the vertex, the x coordinate is the first thing I'm going to find. I'm just going to average or find the middle of 1/2 and -1/2. And that is 0. And then I'm going to use the x coordinate to find the y coordinate. So I'm going to say that y equals 4 times 0 squared minus 1. So it's 0 minus 1, so y equals 1. So my vertex, so these are the x-intercepts up here. My vertex is at 0, 1. And in this situation, the y-intercept is also going to be 0, 1. If you remember, all we do for a y-intercept is to put 0 in for x. And if you guys are starting to notice, it looks like the y-intercept is always going to be that constant term, and we'll fine-tune that again. So 0, 1 is the y-intercept. And now I can graph my parabola. So I'm going to draw in my coordinate grid, or draw in my axes. I believe this time I'll just count by ones. and 0, 1 is my y-intercept and my vertex. My x-intercepts are going to be right here. In this situation, it might be helpful to, we're going to get 2 more points. Sometimes it helps. I'm going to use x equals 2 just so I can get a nice picture. No, actually, I take that back. I'm going to use x equals 1. So y equals 4 times 1 squared minus 1. So that's 4 times 1 minus 1, or 4 minus 1. So it's 3. So when x is 1, y is 3. When x is 1, y is 3. And then, of course, since we know, and I'm going to highlight this, this is our line of symmetry right here, going right through the y-axis, then I can go just to the other side of it and have a nice mirror image. And then I draw in my parabola. Here we go. A little bit messy there. Let's fix the parabola a little bit. I tend to draw the curve starting at the vertex and then going up one side and up the other side, or down, vice versa, however it is. But that gives us our picture. So that gives you a couple of examples. There are 2 more examples on this worksheet, on this PDF, that I'm going to attach it to the assignment as well. I want to go ahead and leave 3 here if you want to practice. You can see the attached PDF. Helps if I spell. See the PDF that I've put in Google Classroom. I would suggest trying number 3 and trying number, all my kids know I do that all the time. And try number 4 on your own. They're just like example 1 and example 2. I will be going back over those on Wednesday. The last thing I want to do, I'm going to look at a couple of these here. I just want to talk very briefly about the zero product property again and remind you that the zero product property says that when a product is equal to 0, then A equals 0 or B equals 0. We're going to use that to solve for x. I'm going to solve the first 2 and then I'll leave the second 2 for you guys to practice with. Again, those are practice problems. They're not necessarily homework problems, but I would recommend you stopping the video and trying them and then maybe going back and watching us look through this again. So as you use the zero product property for this first one right here, we're going to go ahead and factor it into its factored form, so I know it's x and x. And again, if you guys wanted to, I'll do it on the next one, but you could go through the generic rectangle and find your factors that way. But this one, I know it has to be a plus and a minus. And I know that I want a sum. If you're thinking about this, in the diamond problem, the product is negative 12x squared and the sum is negative 1x. So it's got to be negative 4x and 3x. So the 2 numbers are negative 4 and 3. So we go through this. So that means that either we've got 2 cases, x plus 3 equals 0, or x minus 4 equals 0. So x would be negative 3, or x would equal 4. That means the x-intercepts would be at negative 3 and 4. But this just says solve for x, so I've done that right here. And if x is either negative 3 or 4, it's going to make that product equal to 0. All right, and then let's do part B. So part B, I'm going to go ahead and review the idea of the generic rectangle. So this would be a situation where we would have 3x squared here and negative 6 here. We know that when we do our diamond problem, the product would be negative 18x squared, and our sum is negative 7x. So it's going to have to be a plus and a minus. Essentially, that means you want factors of 18 that have a difference of 7. So I know it's going to be 9x and 2x, and then it's just a matter of making it negative 7. So it'd be negative 9x and 2x. So if I go through and factor it, it looks like my two factors are going to be 3x plus 2 and x minus 3. And let's double check that. Yep, that would do it. So that means for my x-intercepts, either 3x plus 2 equals 0 or x minus 3 equals 0. This one's easy enough. X is going to equal 3. This one takes maybe a little bit more work on your part. So we get x equals negative 2/3. So my two solutions here are going to be x equals negative 2/3 or x equals 3. And in either case, if x is either one of those numbers, then my outcome is going to be 0. And that's what we call the zeros or the roots. So like I said, I'm going to leave 2 more here. I would be careful if you practice C, just note that it's not in standard form. So put this one in standard form first. And then go through the product using the zero product property. Again, like I said, I'm just leaving a couple for practice. It's up to you if you want to try them or not. I would suggest trying them. Note that I'm going to start Wednesday's lesson by going over them. So if you try them and then you have them right, you're good to go. If not, you might want to ask some questions in the next couple of days, because then on Friday we are going to ask that you complete one of these and submit it on your own. And we just want to make sure that everybody's understanding what's going on. So let me know if you have any questions, or let Mrs. Huckel know if you have any questions, and I'll see you back in Google Classroom on